All right.
Borde vara den som är
All power.
Welcome to the Evolution Show. I'm Johan Landgren. If you're new to the show, I'm a full-time investor and writer in sustainable tech. And on the Evolution Show, we bring inspiration and talk about smart energy solutions, electric transports, AI, and inspiration for sustainable living. And today, I have a really inspiring guest for you on the show, Anders Forslund, the CEO and founder of Heart Aerospace, one of the world's most talked about startups in the electric plane space, and a world leader when it comes to developing a fully electric commercial airplane. Anders Forslund shares the latest from Heart Aerospace about the 19-seater electric plane they are developing outside Gothenburg here in Sweden, and why the plane already today attracts customers like United Airlines and several others for regional aviation. In part 2 of my conversation with Anders, we look closer at Heart Aerospace plane and learn more about how it will work, so you definitely want to stick around for that. I hope you like the content, and if you want to support the show, we really appreciate a thumbs up. And consider subscribing. As always, stay ahead of the curve and stay electric. This is the Evolution Show. Welcome to the Evolution Show, Anders Forslund.
Thank you.
Yeah, I realized that this is actually the third time you're on the show. I think it was about 2 years ago we met first time, and so much has happened for Heart Aerospace since then. I think just a year ago when we spoke last time, Heart Aerospace, since then Heart Aerospace has flown into the center of the radar, we could say, the electric plane radar in the world actually. I don't think that's an exaggeration. I think it's really that's the case, because for people who don't know about Heart Aerospace and what you do, can you please tell us about Heart Aerospace and a little bit about yourself?
Yeah, sure. So we're Heart Aerospace. We're a Swedish startup building electric planes. We're currently working on an aircraft called the ES-19, which is a 19-passenger aircraft that is targeting regional routes. And we started this, and it's driven entirely by batteries and electric motors. We started this company in 2018 when Norway announced that they wanted all of their domestic flights to be 100% electric by 2040, and we saw that there was nobody really catering to that demand. We were part of Y Combinator in 2019, where we did our first fundraise. But I think since we last spoke, we've also closed our Series A round. So we had another investment round led by Breakthrough Energy Ventures, which we think is the most influential climate fund in the world, and also an investment in a large order of 200 aircraft from United Airlines and Mesa Airlines in the United States.
Yeah, I was actually going to talk about that, but if we talk a little bit about yourself also, I mean, you have a PhD in aerospace engineering.
Correct.
And you've told me before also, and when we talked last time, that you have obviously a great interest in aircraft and aviation since you were a really young guy. But so I guess you have a really great interest obviously into planes. Could you tell us a little bit about that?
Wow, yeah, so it's funny because we're at Säve Airport here in Gothenburg, Sweden, and it's actually about 3 minutes from where I grew up. So when I was growing up, as a kid, this used to be a military airport, and there used to be air shows and all these stuff, and I remember, seeing the Viggen planes, the old Swedish fighter jets, flying very low over the soccer fields where we play football, so it was kind of funny that we'd end up here, and I was always drawn to planes, but also space has been something that I've been passionate about. And when electrification came, and I was at MIT in 2014, when it was like exploding around drones and electrification, and decided to spend wanting to spend my working life, my career working in this. And after sort of the big Norwegian announcement, we decided to set up shop actually very close by here in Sweden. And yeah, so it's quite a journey actually. We started this company only about 3 years ago. We were 2 employees, 2 full-time employees 2 years ago. Now we're, I think, we're signing on new people every day. We're approaching 70. It's exciting every day to be working on this project.
Yeah, and we can see behind you, you have actually the first electric motor you have developed. And last time we spoke, you have just had it delivered. Now it's mounted until this until this nacelle.
Yeah, we have one there, and we have one here that's for testing as well. So we have actually two of them here, and we started testing this actually about a year ago. And now this is a separate rig that we use only for motor and motor electronics testing. Yeah, there's a lot of testing that's being done and to be done in the future as well.
Yeah, and today I thought we could cover some of the latest milestones Heart Aerospace have had so far, and the benefits obviously by going electric, and why this is possible for regional flights today. Because I think most people, they might think, yeah, electric airplanes and aviation, that's in the future, far in the future. But you're talking often about this, that it's in terms of regional flights, it's actually a business case already today. So, but let's start with some of the basics for people about electric planes, because either people, when they hear about electric planes, it's like, yeah, they love them, it's a fantastic idea and it sounds great, or they're a little bit more skeptic. They think about electric planes like, how can they really afford fly that far, across the Atlantic? That's not possible. So why should we go after electric planes right now? So could you tell us a little bit how electric planes could make economic sense today already, and why the battery range is sufficient? What's the business case?
Yeah, so it's really important, and maybe I can tell this through the spectrum of our latest, something that we're very, very close to right now, which is the United Airlines and Mesa business case. So essentially today in aviation, you're using the same type of propulsion, whether or not you want to fly from Europe to Australia, which you can do in a single flight, or if you want to cross a fjord in Norway, or if you want to fly to a ski resort from Denver in Colorado. And we think that this is a little bit odd, right? So, but actually, if we go back a few years, only to about the 1990s or 1980s, there was a vast infrastructure of 19-seater electric aircraft, hundreds of them flying to hundreds of communities across the United States, operated by companies like Mesa Airlines, which is actually the largest operator of 19-seaters in the world. To actually, many of these short routes to small communities. What's happened since is due to the bad unit economics of putting a jet motor on a small plane that carries, that flies a short route. These routes have been deemed uneconomical. I mean, you shut them down, and a lot of people have lost access to the air travel network. By switching the most expensive part, the most maintenance prone part of an aircraft, which is the which is the turboprop, to an electric motor like the one we have here, that's essentially like one moving part. You're reducing the cost of acquisition of such a system by about factor 20. You're reducing the maintenance cost of the motor by about 2 orders of magnitude, and you're also getting beneficial unit economics by replacing jet fuel with batteries. So all of a sudden you're in a place where you can start flying these routes. Now, maybe I didn't mention that, but the average route length when Mesa operated these 19-seaters was about 172 miles, which I think is about 270 kilometers. So they didn't stop flying these aircraft because they didn't fly far enough. They were not thinking, oh, if only my 19-seater could fly to Australia. They stopped flying these because of these bad unit economics. So this creates a perfect early business case for electric planes that we can deliver with the technology that we have at our disposal today. Obviously, this is not the end of the line for electric planes. Now, we believe, I think it's a long way off before we can fly across the Atlantic, but to be able to do longer and longer routes as batteries improve, as they progress. But we don't have to wait. Like, we have this perfect early application here, and we can create flying that's, I think, first of all, 100% green, but also affordable and be more accessible, integrated into the fabric of society, and especially sort of for people that are living far away from major hubs.
Speaking of economics, you mentioned one of the obviously, I guess, your biggest milestone so far with the contract with United Airlines. So they've ordered 100 of your planes, and the Mesa Airlines another 100 airplanes. So can you tell us about this partnership and what does it mean for you going forward?
No, I mean it's obviously pretty exciting. The United States is the biggest market in the world, the biggest single market in the world for aircraft, and so Mesa Airlines was also, I think, has more operator knowledge of 19-seater aircraft than any other airline in the world. They are also and supported by United Airlines. So just to because I talked about these two airlines kind of interchangeably. United Airlines generally operates with subsidiaries when they're flying, or subsidiaries or regional partners when they're flying the smaller aircraft, the regional routes. And Mesa Airline is one of those partners that have flown a lot with United. So if you're flying United Express, for instance, one of the operators can be Mesa Airline. And United is seeing this as an investment into the future. They are one of these airlines that was very early on declared that they want all of their they want to be net zero by 2050, and they're not waiting around, which I think is really important. They are investing in the technology now, because now it's when it matters. It might seem a little bit it is actually like progress does not come automatically, and you're actually shifting. We don't know anything, or we know very little about how the world will look in 2050, both in terms of technology, climate, and all of this other stuff. It's a very moving target. It's a different world that we're heading into. But we know one thing, and that is, a year saved in the 2020s will be a year saved by 2050 as well, because progress does not catch up with itself automatically. So if we can get an aircraft in the air by 2026 instead of by 2035, it really matters for 2050. And I think they've been really, I think, sort of visionary and forthcoming enough to realize this, and realize that if we want to meet these goals by a few decades, we have to start making these investments today, because that's how we get the ball rolling.
In the next episode, we're going to talk more about your planes, the Heart ES19. Yeah. But one question that is obvious that people, I guess, will think about is the infrastructure surrounding the planes. Yeah. So how are you planning to recharge the planes? People might wonder, when the plane is, going to have a new takeoff after, a full charge or a long trip. How long will it take, for example, and how do you plan to solve this?
Yeah, actually, we're, from a technical standpoint, our assessment is that the technology is mostly already there. From a charging infrastructure, we already have chargers that can perform. So we set out an early sort of rule of thumb guideline of what we wanted to charge, and that's say that for every 2 minutes in the air, it's going to be 1 minute of charge time. And since we're flying these short routes that are under an hour, there'll be under half an hour for charging. It looks like that is actually not only realistic, but rather conservative. We already have the charger, the people that are developing chargers for trucks like ABB already have the charging infrastructure to meet and exceed these requirements significantly. The only issue then becomes the batteries, and making sure that the batteries maintain their integrity. Fast charging is something that can impair battery performance if batteries are being heated. So we're looking at some sort of, or we're looking at charging that is also preconditioning the batteries and cooling the batteries while charging. So.
Yeah, that sounds great. So that solves there is basically no problem today if you're going to travel the way you're.
There are obvious issues, but the issues are not necessarily technical. It's more about, there's a rollout that's required here. There's airport personnel that needs to be trained. there's just a little bit of, these processes take time. And so, I mean, as I mentioned, we had Avinor here, the big operator, or the airport operator in Norway here to discuss exactly these matters. It's sort of, it's not that it's any new technology or anything that's substantially different from what's out there, but it's also, rolling it out to airport, making sure that it conforms to all the requirements for aviation, and that also that you train the ground personnel and all that stuff. So it's not trivial, but it's definitely one of the, I mean, we can touch upon that later, but one of the big advantages I see for electrification, there's a lot of different concepts being discussed, like hydrogen, etc. But one of the big benefits of electrification is that it's actually getting you're piggybacking, you're getting a lot of synergies from what's happening in the automotive industry.
Yeah. But as I understand it, the main reason why we don't see, the 19-seater planes today is because there are either too few regional airports operating them today, and you mentioned that the issues related to that because of operating, the fuel infrastructure, maintenance, or costs, of course, for these planes, for the traditional planes. So it didn't make economic sense after the 90s, mid-90s. But with an electric plane, that equation changes fundamentally, and you've touched upon it already. But why is that?
No, it's really about, we were actually, and it was interesting when we were having these early discussions with Mesa Airlines and United Airlines, and understanding that the way we describe the problem, as being, the maintenance of the turboprops is part of the big problem why we don't have it. And they were like, no, it's not just part of the problem, it's the essence of the problem. And we were almost afraid to say that ourselves, because we didn't want to sort of present it to. So it was, it is that, it's technology. It doesn't make, I mean, if you think about it, like, it doesn't make sense to have the same technology flying a 19-seater for 100 kilometers as it is flying 300 people to Australia. I mean, why should that make economic sense? It's kind of a very much of a one-size-fits-all for, and a jet engine is kind of a very, it's not the most, compare an electric motor with a jet engine. An electric motor is something that is very scalable. It's the same technology on our 19-seater aircraft as it is on a small, racing drone, or in your toothbrush almost, right? But for electric jets, they come in different sizes, but they're generally just working on one operating point. The unit economics of building a jet engine is, the complexity of it doesn't really change that much depending on size. So it's expensive whether you put it on a 19-seater or a 70-seater. It's roughly the same price. So it's one of those things, and I think we're constantly, when we're describing this, obviously we don't want to be describing a world, you don't have to be too futuristic to imagine this. But it is, we have to be aware of, when we look at what aviation is today, that we are shaped by our experience of it. So we tend to look at a new technology and value and assess that on the merits of what the old technology does. And that's why we end up a lot in range discussions about, you cannot fly very far, but then that's really not the point. So,
no.
Yeah.
Yeah. And an electric airplane has other advantages as well. And one of them, of course, is that they're much more silent. Yeah. Than traditional airplanes. What do you think about that? What's the, something that people perhaps don't, think about?
Operating this propeller that I have behind me is like, it is vastly different at takeoff and at cruise. Some people, we haven't made the sort of decibel comparison yet, which is something that I'm dying to do, but it's, at least 50% quieter, and a jet engine really only has one gear. It only has one RPM, that it's the operating point. And you can go above and beyond that, but how you generally control it is that you pitch the propeller blade's angle. So when you're doing this in the taxi phase, when you're actually going from the tarmac to the runway, which can be, 10 minutes, for a large airport. You're actually running the jet engine as kind of full steam, and then you're pitching the propeller blades so that they're creating so little thrust that you're not, shooting away across the taxiway, but actually just, moving ahead slowly. So what you're essentially doing is you're instead of creating a thrust machine with your propeller, you're creating a noise machine because that energy needs to go somewhere. Whereas if you have an electric motor, you're at, you have same torque at, 0 RPM as you have at 2000 RPM. So you can run these very slowly with the sort of efficient blade pitch for that speed, and you can actually, like we looked at it, like 2 kilowatts per motor to taxi, and we've tried this with this thing, and you stand next to it, and it's like quiet, right? And that's 10 minutes of people living close to airport having to listen to that for taxi. Now the takeoff is more, maybe 10 seconds or 30 seconds. So the initial climb and all of that. So it makes a real big difference from the duration, and also obviously for the local pollution. So this is one of the reasons that people don't want to live close to airports is because of local pollution. So this is really exciting and really a big thing that I think that people don't realize about it. So it's about, for like 200-kilometer route, it can be up to 10% of the fuel that's being used in taxi for a conventional plane. So you're wasting 10% just traveling 500 meters on the ground.
Yeah. Something you talk about often also that I think it's worth mentioning here is that how you can revitalize regional aviation. Yeah. You talked about this earlier. You gave a presentation at the Chalmers University in Sweden, where you showed a map where United Airlines, and you mentioned this already in this talk, that in 1994 there were hundreds of 19-seater airplanes across America, and this map was very illustrative. And it opens many interesting possibilities to offer smaller communities, making them into, hubs for electric planes, and reachable, obviously, by more people, and opening even new business opportunities. Yeah. So do you agree that the 19-seater electric planes that you're developing could, be, aiding and helping to revitalize regional aviation and traveling to smaller communities, suburban areas, for example?
Yeah, so I definitely think so, and this is the really exciting part, so I mean, this was sort of the unfulfilled promise of aviation. Now when we think of aviation today, we think about the thing that most people maybe do once a year to fly to some faraway destination for their holiday, but it doesn't really have to be that way. I think people, when aviation came, it seems like this is the most efficient way to travel for any distance, right? And that was before the sort of deregulation of the airlines that happened in the 80s and 90s. Small planes operating these when it was more in the sort of common good. It was many state-owned airlines. There was much more regional routes in many areas of the world, including Sweden and the United States. So it is, but the thing about this is, when I'm talking about, having to revitalize this and wanting to create this, it sounds maybe like I'm speculating into a future that we don't know about. But in fact, if we just go across the border here in Sweden to Norway, they never stop doing this. So Norway is a country, a small country, a lot of fjords, a lot of mountains, small population. But it's sort of in their constitution that everybody should be able to go to Oslo over the day to represent themselves to the authorities. So they have a different, so they're subsidizing a regional route network of small planes doing these short hops, and created a very dynamic transportation system around that. Now that works only because the Norwegian government is subsidizing it. And obviously they also want this to go electric, which is important for us. But if we can get the unit economics to stand on its own two legs for the rest of the world, I think the situation that we have in Norway today, which is hopefully what we'll see all over the world within the next decade.
Yeah, and talking about timelines and your plane at Heart Aerospace, you have set a really ambitious goal to have the Heart Aerospace 19 plane, Heart ES19 plane, built and certified by 2026, and that's not far away actually.
No.
I just want to mention that I think I really like your reasoning behind this company and what you're doing, because you stated also previously in the presentation that the importance for a company, and that goes for all startups, to have ambitious goals with the risk of failing or missing the deadline, but also the importance of working towards short-term milestones before you reach this sort of end goal. And I guess the thinking behind this is that to push for innovation forward and to keep your team focused and streamline the development process and so on, you have to set up goals and you have to be ambitious. So I just think that's a great thing, and it may seem obvious for when you think about of course you have to set up short-term goals, but a lot of companies they don't have this approach. So could you share some of the thinking behind this?
And I mean, this is something that I thought a lot about. Well, first of all, like when you set a goal for yourself, there's the Parkinson's law, and I mean this is sort of the amount of time you have is the amount of time it's going to take, right? This is sort of the reasoning behind Kennedy saying that they'll have man on the moon by the end of this decade. That turned out to be true, right? We tend, as human beings, to adapt to those requirements. And it's sort of, for us, the 2026 thing informs every design decision that we make, right? We're building an aluminum airframe. We're not building a composite airframe because we know that that's going to take more time. We're building our supply chain relationships so that people can support us, that we don't have to, build up all of that infrastructure ourselves or that capabilities in-house. The reason that we're building 19 passengers is because we get into a certification bracket, which generally has like a 5-year or less than a 5-year time frame to certification. So it informs me, but more as more of a from a philosophical point of view, I think that we have been in a place. So if you look at, say, since the Wright brothers, I think it's 1903, for the last 120 years. If you were to divide that into two 60-year categories, like one that's going to the 1960 roughly, and one from 1960 to now, the first period was a period of intense. It was not a very stable environment. There was a lot of things happening, world wars, new technologies, transitions of a lot of things, and aviation was working towards that and making a lot of progress. You had everything from, it went pretty fast from the Wright brothers to the first sort of commercial airplanes flying in the 1930s, or actually much earlier than that as well, but sort of getting that established, to the invention of the jet engine, to a plane. If you look like an aircraft, the old Boeing aircraft of the 1950s, to the entree dyne, they look exactly similar to the ones that are rolling out today. Obviously, there's been a tremendous improvement in those last 60 years. You've decreased fuel consumption tremendously, like by, I don't know, a factor 3 or more. You've created much better unit economics of flying. You've built out the route network significantly. So we should say that for the last 60 years, nothing has happened. But the thing that has happened has been this continuous incremental approach of optimizing the subsystem components of the aircraft, which can be done without seeing the full picture. You can build a better jet engine whilst not knowing so much about the rest of the plane. And you could have a long lead times of saying, I'm going to do this and it's going to be ready in a decade or 2 decades. This is not, this is how we are all trained as aerospace engineers. This is the world we're in. This is how, this is the goggles that we're wearing. But I think that the next 30 years are going to be dramatically different. I think that it's, we're seeing, if you do like a pestle analysis or stuff like that, look at the political, economical, social, environmental, technical things that are happening. There's so many things that are changing so rapidly. So I think a 5-year plan about how the world is going to look like in 2026, that's almost like the maximum of what you can plan for. because we don't even know, if I were to build an aircraft for 2035 or something like that, that would be 15 years ahead. It would be in a technology world, it would be in a world, quite frankly, where the public perception of aviation, the legislation, all that becomes very, very difficult. So I think there's such an inherent value in keeping, these 5-year plans. I mean, it's sort of, yeah.
I could just mention an anecdote that I just came to think about. I mean, when people think about the rate of change now, it's exponential. And for people to understand that, you can just mention, the EV market. Some of the EV big automakers, they're talking about, in 2030 we're going to be, only making, fully electric EVs. But in my eyes, as you said, if you look 5 years ahead, so many things are happening. So if you have a plan in 10 years to be in the auto industry, to be fully electric, I think it's game over for many of these automakers if they haven't reached that goal much earlier. So there's other aspects of this, and I also think that you said 5 years, so many things will happen. So you have to think about 5 years ahead, because things are happening so fast.
Yeah, and it's also sort of the whole kind of machine that builds the machine thing of one of the outputs of this 5-year sprint that we're doing is an aircraft. Another output of what we're doing is an aerospace company. And if there's an aerospace company that comes out of this 5 years that can build and certify a zero-emission aircraft, then that puts us in a very good position for the next 25 years after that, up until 2050. Yeah, not stopping, I think, is really important, and just keep moving, keep pushing to the next things, and. So it is really informs all of what we're doing.
So if we talk about in terms of your 5-year plan, you have a goal now to have the plane certified and commercially ready by 2026. So can you say anything about where you are, in terms of the next steps or the next milestones achieving this goal?
Yeah. Okay. So we started in 2019 really, and by 2020 we had the first big major demonstrator, which was the electric propulsion system, which is the size of a small jet engine, this is like a big de-risk, sort of intuitive de-risk, and it's not that we're ready for commercial service yet, but we have identified sort of exactly what we wanted to do. The next biggest challenge about building an electric aircraft, look at our aircraft, it looks very similar to aircraft that have been flowing for the last 80 years or so. So it's not actually getting the aircraft up in the air. Instead, it's proving that all of that, an aircraft is a very complex machine. It's one of the most complex machines that we have. And there's a bunch of subsystem on the aircraft, the avionics systems, the flight control systems, the environmental control system, cabin pressurization systems, and de-icing systems, which is really a big deal, making sure that you don't have ice build up on the wings. To show that these can work when you only have batteries as power or as energy, and showing that can work in every corner case, in every weather condition, and that you can meet the certification requirement. Now, aviation is the safest form of travel for a reason, because there's so heavy certification requirements. So the next thing we're building is this big demonstrator to demonstrate all of these subsystems. And we're also going then, so we're acting a little bit like a system integrator. We're essentially building a Lego kit from a bunch of different technologies that's being developed by our supply chain. So the big thing becomes being that system integrator and growing those relationships with the right suppliers. And this is not just how a startup does it. This is how the big OEMs do it as well. You find suppliers for airframe, avionics, flight controls, and every subsystem. And then we just need to find the right suppliers, make sure that the architecture is sound, make sure that we know where everything goes, where everything fits, making sure that we thought about all the certification requirements, so that, from the top level down into component level, so that we're asking the right questions to the suppliers and putting all of that together. And we hope to have achieved that and have a demonstrator of that next year. So in fact, I'm looking at the early parts of the demonstrator here in front of me, but I will not show it yet. But it's pretty exciting. But once we have that, we can say, okay, we're ready. We go through the sort of preliminary design review and then the critical design review, and we can start asking our suppliers to start manufacturing these things, build the tooling, and only like in 2024, that's when we'll be ready with that. And then we can get all this stuff together, get it to our facility, and start doing flight testing of this aircraft. And that will then the flight test aircraft will be done on the same sort of production tooling as the early production aircraft. So it's actually very, very close to being production-ready aircraft. But you need still to do about 2 years of flight testing and test in every weather condition. Sort of, it's like you have 3 flight test vehicles, and then you're increasingly adding more. On the first flight test vehicle, kind of a bare bones plane, and then you're building more stuff into it and testing all of these stuff. And so yeah, it's an intense process, but it's one that is following a recipe that has been done by many companies before us. It is something that is very regulated how you do this. So actually, when you start investing, you agree on a certification basis early on with the authorities, so you know what you will have to prove and what you will have to do. And so it's just about building the right team and the right supply chain.
Yeah, and finally, I mean, as a testament to your the interest of planes for regional aviation right now, aside from the U.S. orders, there are also smaller markets like Norway and New Zealand.
Yeah.
And they have earlier this summer, Sounds Air in New Zealand, an aviation air company in New Zealand, ordered 3 ES-19 planes, for example, already. So, I mean, why do you think there's such a big interest for the Heart ES-19 plane right now?
We're catering to a demand that understand that people, the operators understand, that they are familiar with. I think they're appreciating our sort of approach to innovation, where we're sort of not trying to reinvent the wheel, but rather focusing. I mean, the airlines are ultimately those that are responsible for their passengers' safety, and they are also, I think they care mostly about the safety and reliability of these airplanes, but also about the unit economics of operating them, and they see in us a project that is taking those questions front and center.
Yeah. And finally, since the Evolution Show is all about, inspiring positive change for a sustainable planet, and Heart Aerospace clearly works towards this goal. It's very exciting to hear what you're doing, and I think I'm inspired, and I hope others are as well. I mean, if you're interested to just work at Heart Aerospace or learn more about you, or I know that you're hiring. So what kind of people are you looking for right now?
We're actually building a quite diverse team. But I think a common denominator is that we are hiring a lot of people that have worked in the aerospace industry early on, because we need that experience. But we are about approaching 70 people. We're 16 different nationalities. We're actually I think 17 or 18 of us are Brazilian. So we're more of a Brazilian team than we are a Swedish team. Actually, we have a lot of people from the UK, and as I said, 16 different continents, or 16 different countries, I would say. So it's kind of a mix. You need people that have that experience, but also maybe diverse experience of working in a few different companies in a few different countries, so that they have that experience coming to a startup. And every aerospace company is different, and when you're coming to a startup, you also have the responsibility to create the culture and the processes there. And people that have been on a few of these journeys are tremendously useful. So, for instance, our CTO, he's worked on aerospace programs in both the UK, Sweden, and also the United States. So he has this, very good frame of reference for exactly what it is that we need to set up in a company to make it work. So, but besides that, I would say, as a final plug, Chalmers University here, my alma mater here in Gothenburg, just opened their master's program with the new mobility focus, and they have an aerospace. There's an aerospace program there, so we'll work a lot with that as well. We're bringing talent from all over the world, experience from all over the world, but we also want to bring in a new generation, and that's going to be sort of our next wave of people coming in here. and getting them to build something new from the ground up. And so yeah, we're really excited about bringing more young people in. It's sort of different from an aerospace company because you cannot just hack this you cannot just you need the initial experience in doing it. It's maybe similar from a tech startup, dissimilar from a tech startup, but once you get that going, you can employ some of that same dynamics in getting young people in that want to work hard and gain experience fast.
Yeah, thank you so much, Anders, for sharing an update and what you're doing. In the next episode, we'll talk a little bit more about the plane specifically. So for everyone interested in that, stick around. I really encourage people to check that out. But thank you, Anders. Really interesting. I hope to see you in the next episode.
Yeah.
I hope you enjoyed today's episode. Tell us what you think in the comment section below. And if you like the content and you want to support the show, we really appreciate a thumbs up. And consider subscribing. And you definitely want to stick around for next week's episode for another inspiring talk with the CEO and founder of Heart Aerospace, Anders Forslund, to learn more about the 19-seater airplane the company is developing here in Sweden. As always, stay ahead of the curve and stay electric.